Imagine standing on a high plateau, watching three rivers diverge toward distant horizons. Cosmologists face a similar fork, but the currents are written in spacetime itself. First, the Great Freeze. If dark energy is indeed a cosmological constant pushing with a steady, unchanging pressure, the universe will race outward faster and faster. Galaxies will slide beyond one another's reach. Stars will exhaust their fuel. Black holes will evaporate in quantum whispers. And what remains will be a thin mist of lonely photons, cold, silent, and endlessly expanding. Second, the Big Rip. Should dark energy's pressure grow even a little stronger, physicists label that change with a single number, W, and the fabric of space begins to stretch faster than gravity can mend it. Clusters unravel, solar systems peel apart, planets, and finally, molecules themselves are torn loose. A trillion-degree fever ends everything in a final breathless instant. Third, cosmic bounce. If dark energy one day reverses sign or hidden curvature tips the scales, expansion could slow, halt, and contract. Galaxies would drift back together, temperatures climb, and the universe might collapse into a searing renaissance, perhaps even rebounding into a new Big Bang. We do not yet know which river we follow, but every telescope, every particle detector is a sextant on this journey, measuring tiny shifts in redshift, mapping distant supernova, asking, how fast, how long, which way? Our universe faces three destinies: freeze, tear, or return, and the quiet pressure of dark energy holds the deciding vote. On a clear night, our galaxy feels crowded. Orion's belt, the Andromeda smear, a billion suns spangling the dark. Press the cosmic fast-forward key, and that bustle thins with startling speed. Space itself is swelling. Every distant galaxy already speeds away. In a few trillion years, their light will outrun even photons, slipping beyond an ever-closer event horizon. What remains is our local neighborhood. The Milky Way, merging with Andromeda and a handful of dwarfs to form one swollen spiral, Milkdromeda. Outside that island, nothing new will ever sail in. Future astronomers, perhaps living in glittering habitats orbiting long-lived red dwarfs, will look up and see only their own collective home, adrift in blackness. The cosmic microwave background will have stretched into radio silence. The evidence for a Big Bang will lie beyond any instrument they can build. Time, too, grows provincial. As expansion accelerates, clocks tick differently for regions separated by great voids. Eventually, there is no shared now broad enough to span what once was our observable universe. History itself becomes local lore, written in star streams and fossil photons trapped within Milkdromeda's halo. Yet isolation is not emptiness. Inside this future island, stars will still ignite, planets will still circle, and curiosity will still ask questions. Even if the larger answers lie forever over a widening sea, cosmic acceleration will leave us marooned on a single galactic island. Proof that the sky's richness is a temporary gift of our epoch. Imagine a city whose skyscrapers look carved from granite, yet over eons crumble grain by grain into dust to find a sea. Some cosmologists wonder whether the unseen scaffolding of the universe, dark matter, might be just as fragile. The leading candidates are famously long-lived, but long-lived need not mean immortal. If a dark matter particle carries even the faintest impulse to transmute, the cosmos itself becomes a slow-motion chemistry set. The numbers are dizzying. A half-life of 10 trillion times the age of Earth would still let a measurable drizzle of decay products seep into space today. Satellites such as Fermilot and AMS comb the sky for extra positrons and gamma rays. Tiny flashes that could be the dying breaths of dark matter halos. Deep underground, detectors like Super Kamiokande listen for neutrino murmurs that might rise as those halos shed mass. The stakes reach far beyond particle physics. Should dark matter slowly evaporate, galaxies would lose the invisible glue that holds their stars in graceful orbits. Spirals could unwind, clusters disperse. And the large-scale web we mapped earlier would dissolve into ever-thinning filaments. Black holes, fed less generously, would slim before quantum evaporation finishes the job. We have not yet caught the culprit in the act. Every claimed excess battles, astrophysical alternatives, pulsars, cosmic rays, statistical flukes. But the search continues, because a single confirmed signal would rewrite our cosmic timetable, turning eternal structure into a passing phase. If dark matter can decay even unimaginably slowly, the universe's bones will one day turn to dust, reshaping the distant future we thought was set in stone. Human curiosity rarely accepts a cosmic forecast at face value. We reach for tools, even when the sky's timeline mocks our own. Faced with an accelerating emptiness, futurists sketch audacious blueprints, grand designs to gather warmth, preserve memory, perhaps outrun the dark. At the modest end lies the Dyson swarm. Billions of solar collectors orbiting a star, siphoning its light before expansion dims the night. Over millions of years, a civilization could migrate from star to star, building fresh shells as old suns fade, an endless relay powered by fusion's last embers. But acceleration is relentless. Eventually, neighboring galaxies slip past any attainable speed. One proposal counters with galaxy herding. Using gravitational slingshots around stars and black holes, advanced cultures might nudge select dwarf galaxies inward, assembling a bound archipelago before the cosmic tide pulls everything else away. Computer models suggest the energy cost is titanic, yet not forbidden by physics. Ambitious, yes, but ambition is a human constant. Further on the speculative horizon sits vacuum energy mining. Quantum field theory allows, in principle, the extraction of work from the negative pressure sea that fuels dark energy itself. Most concepts collapse under practical scrutiny. They demand machinery of planetary mass or perfect control over spacetime metrics. But the idea underscores a deeper truth. Future engineers will treat today's metaphysics as tomorrow's resource catalog. In the end, these thought experiments are less about blueprints than perspective. They remind us that even in a universe racing toward solitude, creativity can widen the path, turning a fate accepted into a challenge engaged. Cosmic acceleration may script an ever lonelier stage, yet imagination drafts counterplots, from harvesting starlight to shepherding galaxies, showing that agency can persist even as the universe slips away. Pause and consider the proportions. For every kilogram of familiar atoms, trees, oceans, our own beating hearts, there are 25 kilograms of dark matter and 70 of dark energy. We move through a cosmos in which the visible is garnish, not entree. That imbalance forces an unsettling question. What do we mean by real when 95% of reality hides from sight? For most of history, real meant tangible, stones underfoot, fire on the hearth. Then came air, germs, radio waves. Realities detected only after instruments extended our senses. Dark matter and dark energy push this progression to its silent extreme. We know them only by influence. Stars whip round unseen mass. Distant supernova fade more than gravity alone can allow. The entities remain invisible, yet their fingerprints are everywhere. Philosophers call this inference to the best explanation, accepting an unseen cause, because every observable path points toward it. Scientists call it humility in data service. The lesson reaches beyond astrophysics. Much of what shapes human lives, trust, culture, consciousness, X's invisibly yet undeniably. In that sense, studying the dark sector is not an escape from the human condition, but a mirror of it. Perhaps future detectors will illuminate the shadows, revealing new particle families or rewriting gravity's script. Or perhaps the darkness will endure. A permanent reminder that knowledge grows outward from islands of certainty into oceans forever beyond our lanterns. Dark matter and dark energy teach us that the most influential parts of existence can be those we never directly see, inviting a broader and humbler definition of reality itself. We have journeyed from galaxies that spin too quickly to supernova that fade too fast, from decaying halos to far future megastructures. Thread by silent thread, the dark sector has revealed itself not as an afterthought, but as the loom upon which cosmic history is woven. Invisible mass sculpted the first stars. Invisible energy now stretches the stage on which those stars perform. In darkness, the universe both begins and quite possibly ends. Yet amid that vast obscurity stands a luminous detail. Understanding has grown. Glass lenses, chilled crystals, and patient mathematics. A small species on a small planet has mapped forces it cannot touch. Each unanswered question, what is a wimp's true nature? Will the vacuum forever accelerate? It's not a void, but an arrow pointing forward. In the closing moments of this episode, we will step back and listen. We will let Vera Rubin's quiet data, the whispers of distant Type Ia supernova, and the steady pulse of microwave background photons merge into one grand dark symphony. And we will ask what it means for science, for culture, for each individual heartbeat to live in a universe whose dominant ingredients lie forever beyond the eye. Join us for that reflection, where the unseen becomes a source of wonder rather than unease, and where the limits of knowledge mark not an end, but a horizon. Ahead, in our final coda, we'll hear how every sunrise owes its glow to forces hidden from sight, and why that truth makes the cosmos more intimate, not more remote. Step outside after midnight, when the traffic hushes and even the crickets pause between songs. Above you stretches a river of light, Milky Way dusted across black velvet. Yet now you know the picture is incomplete. The stars, the nebulae, the moons that stir poets' ink. Together they account for little more than 5% of all that is. The rest moves invisibly, shaping every orbit, every sunrise, every breath of cosmic history. It was Vera Rubin who first heard the dissonance. Spiral galaxies spinning too quickly, as though gripped by ghostly hands. Decades later, distant supernova added their own off-key note, dimmer than gravity alone could allow. Piece by careful piece, astronomers assembled the score. Dark matter is the deep bass line. Dark energy is the rising swell that carries the melody outward. Instruments as different as liquid xenon vats and spaceborne telescopes now play in concert, each probing a register our eyes cannot reach. And yet listen closely, the darkness does not diminish the music, it enriches it. Just as silence between piano notes gives shape to a sonata, the unseen portions of the universe give context to the scene. We value a candle more when we glimpse the night that surrounds it. We cherish warm company because cold space is vast. Knowledge of the dark sector is a reminder that mystery is not the enemy of meaning. It is the medium in which meaning grows. So when dawn returns and sunlight paints familiar colors on familiar walls, remember what rides upon that light. It travels through halos of unknown particles across a vacuum pushed ever wider by unknown pressure, arriving finally at retinas and minds that can know, even if only in part. In that interplay between the known and the hidden lies both the challenge and the romance of science. This is Cosmic Canvas, where the universe is not only studied, but painted in meaning. Until next time, keep asking, keep looking up, and never stop wondering.